Dear friends, we are here to discuss on controllers. There are various types of controllers available, whereas our discussion is restricted to PID type of controllers. This discussion is divided into three parts: part 1, part 2, and part 3. In part 1, we'll discuss the process and the objectives of a control system. In part 2, we'll discuss on individual type of controllers, that is proportional, integral, and derivative controller. In part 3, we'll discuss on composite mode of controllers, that is proportional integral mode controller, proportional derivative mode controller, and proportional integral derivative mode of controller. To understand the importance of controller, it is necessary to know the process. Once the process is known very well, the use of controller will be more easier. In a process control, there are various processes that can be controlled using PID controller. The processes are chemical reactor, distillation column, compressor, pump, heat exchanger, etc. What is a process? Process is a sequence of operation that can be performed to complete a specific task. So figure indicates that a raw material is the input that is fed to the process or a plant, and after processing it comes out in the form of a product. There are certain requirements of the process control. The process control is required for safety, production specification, environmental requirements, operational constraints, and economy. As mentioned earlier, there are objectives of a control system. Those objectives are to suppress the influence of external disturbance. Whenever there is an external disturbance applied to the process, the product quality of the process varies, and hence this should be suppressed before it makes change in the product quality. The control system is aimed to do this. The second objective of the process control is to ensure the stability of a chemical process. Here, chemical process is taken as example. It need not be restricted to only chemical process. And the third objective is to optimize the performance of a chemical process. The behavior or a role of a controller can be analyzed by various ways of analysis processes. There are various techniques that can be used to see the performance of a controller being used. Let's have an example of a process and certain parameters which are associated with the process. Here, a simple example of a liquid tank is considered as a process. Figure indicates that there is a tank which is filled with a liquid at height h. There is an input to the process, that is fluid flow rate and a temperature. The fluid, inlet fluid, which is having a flow rate of Fi and its temperature is Ti. I suffix stands for inlet. Here T indicates the temperature of the fluid inside the tank. The temperature of the fluid to be controlled is sensed using a transducer. It is indicated as T. This current temperature is compared with the set point temperature TSP. The difference between this set point and the measured value of the temperature is calculated and it is known to be a error which is input to the controller. Based on the sign and amplitude of this error, controller is supposed to take a action by providing the required force to operate a control valve. This will change the required steam flow rate FST. This steam flow rate is applied so that the temperature of the fluid inside tank gets changed. The quantity of the steam flow rate is responsible for transfer of heat and thereby increase or decrease in the temperature. Figure indicates that the process, when the various operations takes place, the fluid which comes out of this process is denoted as F, having a temperature T. There are variables which are associated with the processes. Those variables are classified as input variables. Those are disturbance or load variable denoted as LV, manipulated or control variable denoted as MV. The second variable which is associated with the process is the output variable. This could be a measured or unmeasured output variable. The third variable is the controlled variable. This is denoted as CV. It is usually a measured output variable or sometimes unmeasured output variable. When the meaning of these variables are known to us, let's have the exact meaning of these variables with the example which we have. In the figure shown, the manipulated variables are the inlet flow rate, it is the flow rate of the steam, it may be a F also, and the load variable is nothing but Ti. The meaning of load variable is, even though the input flow rate is constant, and if we require the output flow rate constant with a temperature T, but the fluid steam flow rate, the rate of steam flow rate depends on what is the inlet temperature. Based on this temperature, the rate of steam flow will be changed by the controller. The output variables associated with the example shown are temperature, flow rate, and height of the liquid. If flow rate of the output is a manipulative variable, then H will be the output variable. And finally, the control variable Cv is the temperature of the tank fluid and height of the liquid in a tank. So, with these details, we'll proceed to understand the functioning of the controller in part 2.